When we are looking at bivariate data and we've plotted a scatter graph, we have been drawing a line of best fit by eye and a regression line using technology, using our calculators. An important piece of vocabulary that you need to know is residual. And that is the difference between the actual data point and our predictions. So if we look at this section of a graph here, what we have is that this was the point that was plotted, 2,5. And looking at all the data points together, this green line was considered the line of best fit, or it could be our regression line. It works with both. The residual is the difference between the point on the line and where the actual point lies. Now the residuals, this is going to be most useful in your IA. If you are doing an IA where you will be comparing two sets of data and linking them, you may draw a line of best fit, you may draw a regression line, and you will need to see how accurate your line is. So you will use it to make predictions, and then you will compare how accurate your predictions are to what really happened. This means that you are using your line. It's making your IA more relevant and more useful. When the calculator actually calculates this regression line, what it's doing is it's finding the difference between this point and a line, a point on the line. It squares that difference so that it doesn't matter whether the point was above or below, so that the sign doesn't have any change. And then it minimizes that value, the sum of those. So the least squares regression line is the line of best fit that has the smallest possible value for the sum of the squares of the residuals. So when you add together the square of the residual, remember the residual is the value, how far this point is from the line, the y difference, the difference in y between this point and this point that would be on the line. This is going to be useful for your IAs, as is the video on piecewise functions, because in real life, things don't necessarily fit perfectly.